So going back to the increase of our average surface temperature, obviously things that need to be really cold are not going to be cold anymore. And we saw how we saw that temperature is not increasing the same around the world. The places getting impacted the most are those in the Arctic Circle, where it happens to be pretty cold, but really not so much anymore. So these next couple slides are talking about melting big ice. So not thinking about the frozen pond that happens in the wintertime, but looking at 3 places where we find ice in the United States. Not in the United States, but in the world. You've got the Arctic, which is our North Pole. You got the Antarctic, which is our South Pole. And then we also have glaciers. Glaciers are big pieces of ice, and that's actually what we'll talk about first. So glaciers are left over from our last ice age, which was about 10,000 years ago. The northern hemisphere was more or less covered in an ice sheet. It was incredibly cold. Water would precipitate on it, but then freeze over. And these glaciers, while they do move, I mean, we're talking about half a centimeter every year. Honestly, probably not even that much. They're very, very slow moving. They're ice, but there's also soil and stuff caught up in it. But again, they've been around for the past 10,000 years. During the last ice age, we had these huge ice sheets. As we came out of the ice age, they started melting, but there's still remnants of it closer to the north. So there are some glaciers in Glacier National Park, which is in the United States. There's glaciers in Canada and Greenland. So they only exist in the coldest places on Earth today, but they used to be everywhere during the Ice Age. Anyway, what we're seeing is that they're melting. Ice that has been around for over 10,000 years, in the past 100 years, have been melting. And so here's a before and after picture. This is at Glacier National Park in 1928 versus 2004. And you can see how much has melted. I mean, you see this mountaintop on all of that ice gone. 10,000 years it was there. And we did this in less than 100. So obviously it's getting warmer. I mean, the only way to get rid of ice is to melt it. And so now you may look at this picture down here and be like, oh, what a beautiful landscape. This is a habitat now. I agree with you. I think at least what's left behind isn't doom and gloom. It's not like we've now ruined our environment. But what I think it should be doing is setting off alarm bells, telling us that yes, our climate is changing. We are actually seeing it happen. And so it's really hard for people to refute, like, that was just natural cycles. So you're going to tell me that that natural cycle didn't happen the past 10,000 years? That doesn't make sense. So again, of our 3 pieces of ice, our big ice around the world, glaciers all around the world are shrinking, they're retreating, they're melting, they're disappearing. That in and of itself isn't a big deal. Well, it kind of is, which we'll talk about in a little bit. But at least the habitat that it's leaving behind is kind of nice if we want to look for some sort of silver lining. So that was glaciers. Another piece of big ice is found in the North Pole. So if we look at the Arctic Circle, now the Arctic, you can kind of think of it as a big ice cube. There is no land underneath it. With glaciers, just to go back to this previous slide, with glaciers there is land underneath of it. Glaciers do not sit on top of the ocean. Glaciers sit on land. The Arctic does not sit on land. If it were to completely melt, it would be ocean underneath. So there's no land mass underneath the Arctic. And what we're seeing in the Arctic is it's also drastically melting, and we see it most severely in the summer months. So these 2 pictures right here, this is from September 2016, so pretty much at the peak water temperature. And then March 2017, which is the coldest part of the year in the Arctic. And in yellow, what you see is where the average ice extent for the Arctic. This is in September, and in March, this is where the ice should be, where the ice has been. And you can see where the ice isn't. Now, in the wintertime, it's not that bad. I mean, yes, it is smaller than, I guess, what it should be or what it has been. You can see that around here. You can see it a little bit in the south as well. It's not looking too bad, though. But if you look in the summertime, mean, you can see huge chunks of the Arctic missing. And this has huge implications for organisms that rely on the sea ice, the most famous one being polar bears, but there's other organisms out there as well. This also affects the fish life as well. There's a lot of marine life that rely on that sea ice for part of their reproduction, for part of their feeding. It's also, again, similar to the glaciers, it's giving us a warning that we are seeing these drastic changes in our environment, and that although it's happening in the coldest places first, it's going to start affecting the rest of us really soon. If we look at this graph, this kind of puts it even in more perspective. So this says the millions of square kilometers is how large the Arctic was. So in 1980, it spanned about 9 million square kilometers. And in pretty much our year, right where we are right now, we're at 5.75. We're not at half, but we're getting there. And again, this is a huge change, and this is showing us that something is happening. Now, one last piece of ice, Antarctica. So Antarctica is in the southern hemisphere. Antarctica is on top of land, so if all of it were to melt, there would be a continent underneath. That piece of information is going to be more important on our next slide. And the reason I have all these question marks beside Antarctica is because Antarctica is kind of doing its own thing. In some years, it's growing. In some years, it's shrinking. And there's really no rhyme or reason to it. It's actually surprising scientists as well. Now, you may look at this graph and be like, oh, it's at the peak growth of it, it was 5% larger and 5% smaller. So Antarctica is 18 million square kilometers. 5 would be, oh goodness, 0.18 times 5. So nearly 1 million square kilometers it has gained or it has lost. So don't think, oh, these are small changes. They don't make a big impact. They make a huge impact because of how large Antarctica is, but it's not a constant impact. Glaciers, totally melting. Arctic, totally melting. Antarctica, sometimes melting, sometimes growing, sometimes staying the same. And we're not entirely sure why. We've seen that climate change is really affecting the northern hemisphere the most, but not so much the southern hemisphere. One hypothesis is that most of the land is in the northern hemisphere, which absorbs heat much faster than water does. Water is a great place to store heat, but it takes a while to heat it up versus land. We don't really know. But if you take a look at this video that's going to pop up here in a moment, it's a video from NASA who actually compares what's happening in the Arctic to that's happening in the Antarctic. And they give you a little bit more insight about what's going on, but they also kind of admit that they don't really know. We're trying to understand it, but huge climate patterns are hard to understand. Antarctica is really hard to understand. We have tons of satellite images of Antarctica, but it's also cloudy there all the time, so it's really hard to kind of get a really good picture of what's going on. So go ahead and pause here. Watch this video to learn a little bit about what's happening with the Arctic and Antarctic and some of the research that's going on there. Now, if we have melting ice, if you have an ice cube and it melts, it's going to turn into water. Well, that water has to go somewhere, and we've already seen that water going somewhere. We've seen that our ocean levels are rising. This makes sense to us. There's no weird thing going on. It's just you have ice melts, turns into water, water goes somewhere. Now, I need to emphasize, though, where this water is coming from. One place this water is coming from is glaciers. Remember, glaciers are ice, but when that ice melts, you have water. Now, that water is on land because glaciers are on land, meaning that water has to go somewhere. Some of that water will get soaked up into the land, but the majority of that water is going to drain into a river that drains into a larger river, into a larger one until it hits the ocean. This is new water entering the ecosystem. So glaciers are melting, and that's contributing to the rising sea level. The Arctic is melting. But the thing is that the Arctic is an ice cube. If you have a cup of water and you fill it up Or let's put ice in it first. Don't be weird. Don't put the water in and then the ice cubes. You put ice cubes in first, and then you fill it up with water. And let's say you fill it up to the tippy top. You see a little bit of water, but it's all in there. As your ice cubes melt, your water will not overflow. And the reason for that is because we've already taken into account that the ice cubes are in there. The water is already in the cup. It just changed from a solid to a liquid. And so with the Arctic's a big ice cube in the ocean. The ocean has already risen because of that ice cube. All that's happening is the ice cube is melting. So rising sea level is due to glaciers, not due to the Arctic. Now there are some impacts of the Arctic melting that we're not really going to explore, just because it's one additional thing to talk about. But if you are interested in it, definitely take a look at the impacts of the melting Arctic. So glaciers melting are contributing to sea level rise. And by sea level rise, if we take a look at the past, 140 years, ocean has already risen by 9 inches. Now, that actually doesn't sound like a lot. So 9 inches sounds like a lot, but over 140 years, that's really not a lot. But we have lots of infrastructure around the world that is at sea level, that is at below sea level. Hello, New Orleans. So the fact that we're increasing at all is going to impact our coastal cities. We have tons of cities that are on the coast. Pretty much all the big cities around the world are by a coastline because of the importance of water trade. Look at DC. If we look at Los Angeles, if we look at San Francisco, if we look at Shanghai and Beijing, pretty much every large city, Sydney, London, is all right next to a large body of water. So it's not like, oh, this won't affect anyone. Like, this affects a majority of people in the world. People have lost homes. Insurance companies now, if you're looking for homeowners insurance, a lot of insurance companies won't even insure you for flooding damage if you live on the coast. You typically have to pay crazy amounts of money to get insured because the insurance companies are prepared for climate change. They're saying, yeah, we know what's going to happen. We're not going to pay for you to live in this house because we know it's going to go underwater, like the one you see here. Now, some of this rising sea level is from ice melting, such as our glaciers. But actually, about half of this sea level rise isn't just from melting ice, but from another phenomenon referred to as thermal expansion. So this picture that you're looking at that just popped up, this is looking at Miami on what we call sunny day flooding. So if you look, there's not rain clouds, it hasn't been raining, it's a sunny day. And sunny days are hot days. Really any time of the year if you're in Miami. And the thing is with water is that when water warms up, it expands. If you've ever boiled water, you see this. You know this happens. It's a natural process. It happens in the ocean, happens on our beaches. Here in Miami, what's happening is Miami is, again, a coastal town right on the shoreline. And on a very hot and sunny day, that water warms up. And when it warms up, it expands. It takes up more space than if it was colder. But the problem is that around the world, water is warming up. It's not just off the coast of Miami. Our atmosphere is getting warmer, so our oceans are getting warmer. The Pacific, the Indian, the Arctic, the Atlantic, like all of these oceans, all of these huge bodies of water are warming up. And even though they're not warming up a lot, I mean, this off the coast of Miami, this is not how warm water around the world is getting. But when you have an entire ocean that covers over 75% of Earth's surface, all warming up, even at the slightest level, and at the slightest level it's expanding just a little bit, but you have billions, quadrillions, I don't even know the word that's large enough for it, of gallons of water in the ocean, and they're increasing just a little bit in size. That's going to have a huge impact. I mean, it's had half the impact as compared to melting ice. So again, this rising sea level is, again, looping back to that average temperature rise.